Today we're going to watch as a star ends its life. The first stars were much larger than those that we know today, so the details were different. What I'm going to describe is what happens in general to all stars. Eventually, the red giant star runs out of particles that it can fuse to make the carbon, nitrogen, oxygen and other heavy nuclei up to iron that we've seen. Then the centre of the star cools, it contracts and heats for the final time. Even heavier nuclei are now fused at the centre of the star, heavier even than iron. Among the heaviest of these is uranium, which is a well-known element. This fusion is very different from what has happened before, because now to fuse these very heavy nuclei requires energy to be absorbed. So there was no new radiation being emitted by this fusion. So there was no balance of forces anymore between the radiation travelling out and gravity travelling in. Gravity had the upper hand and the star contracted faster and faster. Eventually, the outer layers of the star become so hot that fusion begins here. Gravity is not strong enough to balance the outward force created by this shell of fusion, and the star explodes, throwing off its outer layers in a huge release of radiation, and this is visible from a huge distance as a new star, and so it's given the name supernova, large new star. And a supernova today can be brighter than a whole galaxy of 100,000 million stars. After a supernova, the core of the star is still contracting. The first stars were very large. Therefore, the cores that they created after throwing off their outer layers, the core was very heavy, and therefore it had a very strong gravitational field, so strong that nothing could escape. This is called a black hole. Over the following years, these black holes absorbed the gas that was surrounding them, and they grew larger and larger. We think that these seeds grew into the large black holes we see at the centre of large galaxies, and in fact were probably instrumental in creating those galaxies. Stars which we see today are much smaller than those first stars. Most of them are not big enough to produce a supernova or a black hole. The average star today, such as the Sun, blows off its outer layers when it dies as a planetary nebula, which is a ring of molecules and gas and dust, as we'll see in a later episode. So what happens to the core of smaller stars, such as the Sun, when they finally die? Some are left behind as a white dwarf, which is a dense cluster of atoms about the size of the Earth. If the original star was larger, then the core is also larger and it becomes a neutron star. It's a clump of neutrons about 10 kilometers across and extremely heavy because it's not made of atoms. There is no empty space inside there. It's solid matter neutrons. Other effects of the first stars. The radiation from these first stars travelled out, it had very high energy, and it ionized the gas around it. Ionization means when you take an atom of gas and you separate it into the constituent nucleus and the electrons. You strip off the electrons. So the gas around these first stars was ionized, and that led to the formation of more stars in the future. So the early stars seeded more stars. The second effect of these early stars was that the heavy nuclei, which had been created during the red giant phase, was thrown out during the supernova. And in fact this happens to all stars. Even small stars, the larger nuclei which are made inside it are thrown out in a planetary nebula. These new nuclei, carbon, nitrogen, oxygen and the rest, travel out and they pick up electrons on the way out and form new atoms. And these new atoms are the constituents which will build objects finally, such as you and me, and we'll follow their history during the rest of this story. So thank you for watching, and if you're interested in the history of the universe as a work of fiction, you might like Time Crystal, where you can follow the characters back through history to the Big Bang, having many adventures along the way. timecrystal.co.uk